All right, number 8. Clearly, the cosine gives me the impression that I might find this in the forms involving sine or cosine, starting at number 46 in Appendix B. So I'm looking around here, and I don't see anything like cosine to the n of u over u. No fractions like that. So what I have to realize, in fact, the only one that I see here, let me make sure that that's correct. The only form that has cosine to any power other than 1 or 2 is number 51. It says it's cosine to the n power of u times du. Well, that doesn't look like that's what this is, but if we look at it, it almost is. Okay, so if we're going to use that formula, let's just take a look and see what would u be. Well, u would be the square root of x. So what would du be? Well, we've taken this derivative many times. It would be 1 over 2 times the square root of x dx. Do you see this is almost that? It's the integral of cosine to the third of the square root of x times 1 over the square root of x dx. Same thing. Now, if I could throw a 2 on here, it would be cosine to the n of u times du. But I can't just throw a 2 there without balancing that. This is actually, in the denominator, so this is a 1/2 I'm multiplying everything by. So I multiply by 2 on the outside to balance that out. So applying number 51, you have 2 times the integral. Okay, so this is cosine to the, n would be 3, of course. That's the power of the cosine. So let's apply it. It's cosine to the n minus 1, so cosine squared of u, which is, u is the square root of x, times the sine of u, which is the square root of x, over n is 3, that's the original power of the cosine, plus n minus 1, which is 2, over n, which is 3. Now times the cosine to the n minus 2 would be just 1, 3 minus 2 would be 1, of u, the square root of x, times du. So du would be 1 over 2 root x dx. Okay, and that's what the formula tells us to do. This is what's called a reduction formula. It takes this integral and it breaks it down into the sum of a function and a simpler integral. Okay. So what do we do about this? Well, this is just the cosine of u times du. That's all this is. And we already know that one, right? So let's write this whole thing. Cosine squared of square root of x times sine of the square root of x over 3 plus 2/3 times, okay, the integral of this. What's the integral of cosine of u du? We've done it a million times. It's the sine of u. Of course, this should have a plus c, and we can tag on that plus c there. And now the integral has been found. And we could multiply by a 2 here if we want, but it's not really going to cancel anything out, so I'd stay away from it. But what I'm seeing now is if we do that, ignoring everything I just said, and we add these fractions together, right? This is the same as the sine of the square root of x times 2 all over 3, and so we have 2 things over 3, so we can add it all together. So take a look at 2 times the cosine squared the square root of x times the sine of the square root of x plus 2 sine root x, all of this over 3. If you didn't quite follow that, you should pause this video and verify that this is true, okay? Except for this is 2 times 2, so this should be 4. Okay, because this would be 2 sine x, and then if I distribute this 2 to that 2 sine x, I'd get 4 sine x. Okay, so everything looks good, plus c, of course. Okay, what do I notice here? I have a sine of x and a sine of x as factors of these two expressions. And also a 2 could also come out. So I'm going to factor out a 2 sine root x times the, when I factor out a 2 sine x, or 2 sine square root of x, from here I'm left with cosine squared root x plus 2 sine root x, or just 2 actually, just 2, because I factored out that sine root x. So I just have a 2, and let's see, we could write this all over 3, or just over 3, it doesn't really matter, but over 3 plus c. Okay, so that last step I just factored out a 2 sine root x. So factor out a 2 sine root x, you're left with cosine squared root x. Factor out a 2 from the 4, you're left with 2. Factor out a sine root x from the sine root x, and you're left with 1, so you just have a 2 left. Okay, over 3. Alright, so that's number 8. Number 10 now. So the tangent gives me the impression I'm going to be looking in, starting at 59, the ones of the form, the tangent of u. So we're looking maybe 71. 71 has 1 over plus or minus tangent of u du. Okay, so this might work. So u then would be 5x. So du would be 5 dx. We don't have 5 dx, but we could. We could just say, here's 5 dx, balance that out with a 1/5 outside. So there we go. It's like I'm doing u substitution, but without all of the rewriting with u and everything. I'm just throwing numbers in there because we're so accustomed to it. Okay, so here it has 1 over 1 minus tangent of u times du. If this is u, then this is du. So here we go. Just apply the formula right away. So 1/5. I always like to, if I pull out a constant in some way, I like to write that first and then go right into the formula. So 1/5 times 1/2 is the first part of this formula here. U, which is 5x. Now it says plus or minus. That just means, since it's in the same order, if you're looking at it, it's plus or minus. So since we have a minus, we're going to use minus. Okay, so minus the natural log of the cosine of u, which is 5x. I've lost it. There it is. Minus the sine of u, which is 5x, plus c, and this is 1/2 times this whole thing here. So I'm just going to go ahead and multiply these guys together. I get 1/10 times 5x minus the natural log of the absolute value of cosine of 5x minus the sine of 5x plus c. Pretty straightforward, that one. Okay. So let's go right into number 12. Number 12, since there is an e to a power, I'm thinking probably those integrals are the ones I'm going to be looking at. Let's see, it's starting at number 81 there. Let's see, and number 85 involves the sine, and this may work. Let's just see. It says e to the a times u, okay, that's good, times the sine of b times u. So we don't even have to have the same constant times u in both of these. So then if this is going to work, u is going to be x, and a, the number that's up here with x, is negative 1/2. This is negative 1/2 times x. B would be 2. And let's check du. Okay, du would be dx. It's all working out. Okay, so applying number 85, we get, okay, so exactly the way we see e right now, to the exact same power, e to the negative x over 2, over a squared. A is 1/2, so squaring 1/2 is 1/4. That's actually negative 1/2. Squaring negative 1/2 still gives us positive 1/4. Plus b squared. B squared, of course, would be 2 squared, which is 4. And then we multiply that by a. A is negative 1/2 again, times the sine bu, which would be 2x. And then this is minus b, which is 2 times the cosine of bu, which is 2x, plus c. Okay? So the next thing, we just like to clean this up since this is a fraction within a fraction. That's not so attractive. So how do we do that? This is 1/4. This is 16/4. So this would be 17/4 altogether. E to the negative x over 2 over 17/4 times, I'm just going to say all this because I'm about to rewrite this, just making a slight change here. Dividing by 17/4 would be the same thing as multiplying by 4/17. And the remainder of all this, negative 1/2 sine 2x minus 2 cosine 2x plus c. And how you want to finish this up and simplify it and have its final form look to you, that's up to you. You could maybe get rid of this negative, pull that out here. This could be negative 4/17 and everything in here could be positive. Whatever you feel like doing. But I'm happy with that. I'm going to leave it that way. Okay. So on to number 22. Number 22 says this. So I don't know. I'm just going to take a look at all of these forms. Looking around here, I'm looking at numbers 14 and 15. They're looking pretty promising because they've got a polynomial, actually a quadratic specifically in the denominator. Okay. So this one, I'm going to continue on the next video. I don't think I can do this in 3 minutes.